Okay, 343. So a good question you could ask is, what is a variable? Now, I could explain this a bunch of different ways, but I think the easiest way to do it is to use some Duplo. I've been using Duplo a lot lately, so that's just where I'm currently thinking. Okay, so imagine we had our computer represented by this choo-choo train. Okay, and the train itself is the processor, let's say, and the individual cars are locations in working memory, which is the RAM of the computer, right? And to carry the analogy forward, or the metaphor, if the cars weren't attached to the machine, it would be either free memory or memory of storage on the computer, okay? So right now the train or the computer has memory but no information allocated to it, okay? So what we want to do is think about how to put information into the machine that we can do some arithmetic operations with, okay? So right now we have an empty set of memory. And what we could do is we could put information into memory, right? So we could take this block, which could be a piece of information, and it could be either a letter, right, like the letter S, or it could be the number 9. So we're going to use numbers for now. That's called an integer. And then the S would be called a character or a string. But we're going to use the number 9, the integer number 9, okay? And we're going to attach the number 9 to this car. Now, there's a few things to think about when we attach it to this car. Because this is a location in memory, it'll have some awful address number, like OX9AC. But that's not very useful for us as programmers because we're never going to be able to remember that. So we give it a short form name, which we're going to call orange car, right? So our variable name will be orange car. Now, so orange car, we've set equal to the number 9. Okay. Now behind the orange car, we have the blue car. It would have another memory address like OXCDA, something like that on the actual memory device on the RAM. But as programmers, again, we get confused easily. So we're just going to call this blue car. Okay. And for the example here, you could call this memory location 1, memory location 2, right? So blue car. So now what we're going to do is we're going to say blue car equals the number 8. All right. So here's our value. It could be either G here, right? Or we could actually give it the number 1 as an integer. So what we're going to do is we're going to set blue car equal to 1. Okay. So now our computer, our train, has access to two variables, the orange car and orange car is equal 9 and blue car is equal to 1, which have locations in memory in position 1 and position 2. Now, what we want to do is we want to use our processor, our train here, to ask the question, what is 9 minus 1, right? So what we could do is we could need another variable, right? We would need somewhere to store the result of the question 9 minus 1, or the arithmetic operation 9 minus 1, and that would be yellow car. So what we'll do is we'll go back to the memory, ask for another position. That would be yellow car. Okay, so now we're going to say yellow car is equal to 9 minus 1. And so we could get this value of 8, right? So we put the value 8 in here. Boop. So now we'd be able to say that yellow car equals 8 because it is equal to also the value of 9 minus 1. Or we could say yellow car equals orange car minus blue car. Okay? And so that's basically using a simple explanation what variables are. They're locations in memory that get assigned short form names called variable names, and those variables get assigned values, like integers, or they could be letters. So for instance, this could be yellow car equals G, blue car equals I, and orange car equals S, so that we could have our train be the GIS train, okay? So there you go, there you have it. That is variables in a nutshell.